Okay, on example 1, the function n of t equals 3t plus 1 times 2t minus 1 squared over 4t minus 5 squared describes the number of deer n found in West Virginia if hunting was illegal, where t is the number of years after 1920. The question is, according to this model, what is the population of deer approaching as time approaches infinity? Well, hopefully at this point you're used to the fact that this question is asking what is the horizontal asymptote. Because anytime the x value is approaching infinity, anytime we're talking about the limit as t approaches infinity or x approaches infinity, we're looking for the horizontal asymptote. Now, this function is too messy to put in Excel, or I guess you could actually FOIL all this stuff together and put it in Excel. But the easiest way to do this is knowing the rules for the powers, or the degree of the numerator and denominator. If you would multiply this together, we don't care about all the coefficients, just the degree of it. Well, the degree of the numerator would be to the third power. It would be a third degree polynomial up here, because when you take the 2t and you square it, you get 4t squared, times this 3t would put you up to 12t cubed. So it would be a third degree polynomial on top. On the second one, when you take the 4t and square it, you get 16t squared. So it's a second degree polynomial on the bottom. And when the degree of the numerator, which is 3, is larger than the degree of the denominator, which is 2, then you do not have a horizontal asymptote. Well, if you don't have a horizontal asymptote, then the graph goes to infinity. So the first basic answer to this is, what is the population deer approaching as time approaches infinity? On this, it's not leveling off, because the power up here, the degree of the numerator, is bigger than the degree of the denominator, so it's actually approaching infinity. So that would be the answer to this. It's approaching infinity. So the limit as t approaches infinity on this problem is actually infinity, because there is no horizontal asymptote. Okay. Now on 1b it says, what are the x-intercepts and vertical asymptotes? Well, you find x-intercepts by setting the numerator equals 0. So we'd set each factor equals 0. Setting the 3t plus 1 equals 0, you would subtract the 1 and divide by 3 to get negative 1/3. And on the other one, the 2t minus 1 squared, you take the square root, and then you would add 1 and divide by 2 to get 1/2. So these are your two x-intercepts. To get the vertical asymptote, you set the denominator equals 0. So you would add 5, well, you take the square root, set it equal to 0, and take the square root, and then you just have 4t minus 5 equals 0. Then add the 5 and divide by 4, and you get 5/4, or 1.25, and that's where there's a vertical asymptote. There's a lot of problems like this. This one, what is the function right here approaching as x approaches infinity? In other words, we're looking for, again, the horizontal asymptote on this problem. Another way of writing this with math symbols is, what is the limit as x approaches infinity for this function right here? Okay, same question. Well, the power of the denominator, or the degree of the denominator, would be to the 5th power, and the degree of the numerator is the 4th power. So therefore, the degree of the denominator is greater than the degree of the numerator, and when that happens, you have a horizontal asymptote at y equals 0. So the answer to this is 0. It's approaching 0. In the long run, this graph is going to level off and flatline on the y-axis. What are the x-intercepts and vertical asymptotes for this one? Well, again, to get x-intercepts, set the numerator equals 0. You would get rid of the 4th power by taking the 4th root. Then you just have to add 3 and divide by 2. So you would get 3/2, or 1.5 for the x-intercept. To get the vertical asymptote, set the denominator equals 0. You would take the 5th root to get rid of the 5th power. You would just add 5 and divide by 3, so you get 5/3. X equals 5/3, or 1.67 approximately, for the vertical asymptote. Okay, let's go to E. What is this function approaching as x approaches infinity? Well, in this one, looking at the degree of the numerator, it's a 4th degree polynomial, and the degree of the denominator is also a 4th degree polynomial. So the powers are the same. When the powers are the same, then you have to look at what the leading coefficients are when you would expand this out. Okay, well, if you take the 2 and raise it to the 4th, you get 16, and 3 to the 4th is 81, so you get 16/81. That's what this is approaching. And you only do this leading coefficient stuff if the powers are the same. So that's what this thing's leveling off to. It might look like, if you graphed it, it might look like it's leveling off to 0, but it's actually leveling off to this fraction right here. Okay, on this problem, what is this function approaching as x approaches infinity? Or in mathematical notation, you would say, what is the limit as x approaches infinity for this stuff? Well, instead of getting a common denominator, you can look at each piece individually. On this one, the degree of the denominator is greater than the degree of the numerator. The degree of the denominator is 1, and the degree of the numerator is 0. There is no x up there. So when the degree of the denominator is greater than the degree of the numerator, it levels off to 0. That's just this section. We're looking at each section. So this section is going to level off to 0. This section here, there's a tie. The degree of the numerator is 1, because it's the first power, and the degree of the denominator is 1. So they both are to the first power. When that's true, you look at the leading coefficients then. So this is 3/6, or in other words, 1/2. So this simplifies down to 0 in terms of looking at the limit as x approaches infinity. This would be 0, and this would be 1/2. And 0 plus 1/2 is 1/2. So the limit as x approaches infinity for this function is 1/2. And we'll stop right there on this video.